So the last type of redox chemistry that we'll mention is the reaction of metals with oxygen to make metal oxides. These are combination reactions where we're making new things. An example would be sodium metal reacting with oxygen to produce sodium oxide. Now again, we have to balance this equation, so we need a 4 sodiums plus 1 oxygen makes 2 sodium oxide. Now, once you've made these oxides, they are kind of reactive and they dissolve in water very readily because they're actually reacting with the water. So when we have metal oxides react with water, they actually use the water and they form hydroxides. So we get 2 sodium hydroxide. So metal oxides form bases in water. When we have nonmetals reacting with oxygen, we make nonmetal oxides. An example is carbon reacting with oxygen to make carbon dioxide. And when we start bubbling carbon dioxide through water, it reacts in a reversible reaction and it makes carbonic acid. We discussed this earlier, saying when we make carbonic acid in a double replacement reaction, it can actually go backwards and break down into the carbon dioxide. And then we have an acidic solution. So that's kind of an overview of different kinds of redox reactions. And when we look at what I expect you to be able to do, expect you to be able to recognize redox by changes in oxidation number, to balance equations, to write redox equations when you read information from a problem, to look at the activity series and predict the products in a single replacement, and to be able to think about the chemistry going on. Now, the very end of this chapter, they have a section on stoichiometry in redox equations. I don't talk about this in here because stoichiometry is stoichiometry. Once you have a balanced equation, it doesn't matter what chemistry it is. It can be double replacement chemistry, single replacement chemistry. Either way, you use the coefficients in the balanced equation, and you balance the equation, look at your mole-to-mole ratio, and do the stoichiometry. So they're not any different. That last problem we did in Chapter 4, where we used the ionic equation, that was a redox problem, and it wasn't any different than any others. So I don't see any reason to spend time fussing about that because it's the same as others. I thought our time would be better spent looking at some really difficult problems. Well, at least my students tell me they're really difficult problems. So I want you to look at this first problem. I want you to read it and then think about it for a minute and tell me how you would start.